In this behind the scenes, we're going to explore how to implement polymorphism on type systems that don't support polymorphism. The core problem that we have is that the Q type system is independent of the backend systems that it supports. So we support GraphQL, OpenAPI, and we're working on gRPC. And none of them support polymorphism or other language features that we might want to take advantage of. I think this is similar to the way TypeScript and PureScript are their own languages with their own semantics and rules, but yet they transpile down to JavaScript for execution. I think it's very similar to that. So we want to do something like that, but in Q. What is this polymorphism thing? So the classic example is where you have a generic operation, like reversing a list or merging two lists. You don't care what the actual items of the list are. They could be integers or strings, people, it doesn't matter. And the operation still works. But in something like GraphQL, you have to be explicit about your type. So if you want to reverse a list of strings, then you need a function that takes a list of strings and produces a list of strings. You want to reverse a list of people, you need a function that takes a list of people and reverses the list of people. So that's kind of cumbersome, and we have this ourselves in something like the scalars library or service that every one of the scalars has a collection of operations, many of which are very specific to the scalars, but some of which are just really generic, like the list operations. We still need those wrapper functions, but they should defer to a generic function that provides the same functionality. And I use the word generic because that's also what it's more commonly referred to, or at least parametric polymorphism is more commonly understood as generics in languages like C# and TypeScript and so on. So I have here the Haskell definitions of these concepts, because when we get to ad hoc polymorphism, we'll be modeling our approach on what's known as type classes. But that's a future episode. We'll do a couple of these episodes building on the previous, and getting more sophisticated as we go. So we'll start really simply. So the way you would read this is the identity function takes a type, any type, we'll call that A, and produces another instance of a type A. And the identity function is really just returning whatever you've passed it. So it's pretty simple, but it's important from a mathematical formalism standpoint. More realistically are the examples of lists that I gave. And we'll probably implement that one. But I also want to talk about this one too. This is the map operation, which you're probably familiar with. It takes a function, and that function converts an A to a B, and then it takes a collection of A. So the mapping operation applies that function from A to B to every element of the A collection to produce a corresponding collection of Bs. And that says, well, we need the actual data to be passed so that these functions can still operate. So we need a generic representation of data. Well, in GraphQL, what would be the generic representation of data? Well, objects are passed around as JSON. So I think where we're going to go with this is that the generic functions will operate on JSON. They're getting JSON anyway, so if they were strongly typed, it would just be the JSON conforming to that type. So that's kind of how they already work. In this case, we'll say JSON is equivalent to A's and B's. Or I have also this generics from TypeScript here, and you can see how they've done it. Identity takes this arg, which, you know, if you were doing strong types, they would be number to number. And so you'd have to have an identity function for string to string and so on. They have this any type. So it's kind of like a void pointer or something, and you don't really care about it. But that's not really that nice either. So they've introduced an actual language feature called generics, and its syntax is with this angle bracket T. And that says I can take an arbitrary type called T, and then wherever T appears, that's where you get substitution of the concrete type. And so here's an example of a concrete implementation of this function. It says identity of type string. So by saying this, then the argument you pass in, the type checker will make sure is conformant to this type. So that's what we want to do. This is too trivial. I want to look at, I think reverse is a good example to take a collection of these things. It's more interesting. If it works for that, then we know that it will work for the more simple case. So let's go to a workspace and play with this. So let's create a new workspace. I'll just call this Polymorphism. Care about a workspace service ID. Oops, I misspelled that. I'll fix it here. Polymorphism. Okay, and I don't need these here, so here. Okay, so we said we wanted to do reverse. So let's do reverse and create a function called reverse. And it takes x's, and we said our generic type, so T is a JSON, so it's a collection of JSONs or a collection of T's. This is our generic function, reverse. Okay. And I want to implement its logic. I'll just use a lambda. So I'll take lambda assistant, add that to my workspace, and I can implement the lambda. So what does reverse do? Well, it's taking a collection, reversing the elements, and then returning it. So I can do this by destructuring the input, which is x's, available in the input object, and then I can just return the reverse of that. So we can just see if that works. I'll run this over a quick sample just to make sure I didn't mess anything up. That by adding a couple of JSON objects here. I have 0 and 1. If I run this, we should have 1 and 0. Okay, so that works. Okay, so I think in more realistic scenario, this would come from another service that's just implemented this generic reverse function. We'll just keep this here, though, even though we think it would probably come from another service. Okay, so we want to reverse an arbitrary set of types. So we could do scalars or we could do kinds. I think kinds are more interesting, especially when we get to some of the next more advanced things. We'll use kinds. I'm thinking like we'll do a sort, an arbitrary generic sort. And we want to have a function that knows how to sort whatever item you've passed in, so that the sort operation itself can be totally generic, and we can implement whatever sort algorithm we want to, and then just have that work for arbitrary types. So for person, we'll just say that they have a name, and to make things simple, even though we would never really do it this way, we'll just say that they have an age. Okay, so we want to, in our test here, we want to implement a reverse of a collection of persons. How do we get a collection of persons, and how do we get this to use the generic? So the first thing I might do is just like, let's define a function that's specific to the type, because that's what GraphQL is going to require us to do anyway. Reverse persons, and this takes in the collection of person required, and it will turn a collection of persons. Okay, so we have the definition of what I will call a wrapper function. And I think when we figure out what the pattern is, what we'll end up doing is implementing an assistant, or at least a feature of an assistant, that generates these for the user automatically. I think the way that would work is I'm in, say, this workspace, and I've brought in my generic. And so I probably would want to target this as the source, and I'd use my assistant to then make this concrete. And again, I think this is very similar to this pattern here. We've defined this generic function of T, so that maps to reverse here, and these are our T's. And in this case, I'm making it concrete for type person, and that's like what they're doing here. Identity of string, we're making this reverse of person. So I think that this is equivalent, but what we don't want to have to do is make the user do this. We would just say, use this generic function, assign T, what are these JSON values, to the concrete. In this case, it's person, and then we generate this function. So before we automate that, let's see what the logic is like. So I need a little test harness so that I can call this function, and then I want this function to somehow call this function. So let's define a test harness that'll run this for us. So I could say test reverse And this is on a collection of persons. And we don't need an input because I'm just going to use all of the people that we have for this kind. And it's going to take or produce a reverse list of persons. So this is our test harness. So I need a list. I'll just have it create, actually, let's go ahead and do this. So this has no instances in it, as you can see, but I can add some instances by using the built-in CRUD operation, add person. So I come over here, this is 0, and we'll say 3 and 8, 4. Another one, we'll say Bob, and he's 42. Okay, so if I look at this now, we have Mary and Bob. Great. So we have a list of persons here, and to get that, I will just say all persons, which is this function here. Okay. This is our test harness. I'm going to use this. What we care about is this function here. So this is sort of what it looks like. But let's implement the test function. So I can clear this. Pull all persons, and I want to reverse the list. I don't care about the input, so we'll get all of the persons. So I can just run this now. You can see turns all persons should Bob, so we know it produces the right list. And then we're going to reverse the list and output it. Right, so this won't work now because I have no implementation. So what does this guy do? So we're going to take in a collection of persons, and we're going to produce a collection of persons. And ultimately, we want to call this generic function reverse. But you can see these types don't match up. Q has something called duck typing. So we use that for coercing things that have the same sort of content. But this won't work in this case because JSON from a type system standpoint doesn't have any internal structure. It's just a blob of JSON. Person has internal structure that we can introspect, and we know what the properties are. But JSON doesn't have that. So duck typing doesn't work here. So we need some other type conversion. So again, this reverse person, and we think is going to be automatically generated from an assistant. So it can also generate the little conversion operations. And I think they're pretty straightforward because if you think about what is the payload of person when it calls your function, it's just JSON. So it's already JSON. So if you return something, all you're really doing is returning JSON that when the type system looks at it, just make sure that it has all the fields. Okay, so that's pretty simple then. We have two functions that convert from person to JSON and from JSON to person. Well, those are just serialization functions, right? So they're pretty straightforward. We have, we'll call this person to JSON, or actually this is persons to JSONs. And I'll just keep X's to make it simple. And this is going to take in a collection of persons, but this time, instead of returning persons, it's going to return a collection of JSONs. And we need another one, is JSONs to persons. And X is on. And now we have person. Okay, so now we have the basic ingredients. Straighten this up a little bit. Okay, and then location. So we've already implemented the reverse, but we just need these two conversion functions. So what do? Well, coming in is a collection of persons, which to us is just a collection of JSON, which is all we need to return. So there's nothing really to do here. We just return what we get. So we return input X's. And the same is going to be true for this one. So wait for the save. And we'll just implement the same lambda over here, because we have a collection coming in of JSON and going out is person. But we're assuming that what's coming in is a person object, which are just JSON. So there's nothing really to do. So if I were to, let's just test this chain here with one instance. Nothing really to reverse, it's just this. Okay, so let's go up a level. And this function. So now we get Bob and Mary. So remember, if we run this one, we get Mary and Bob. So it works. Mary, okay. All right, so this is the basic idea. In the next episode, we'll talk about what this looks like in code, because we can effectively do all of this. Well, not this all persons, but this in this reverse persons. Everything we just implemented can be synthesized. So we want to implement all of this in a single lambda. So that single lambda will do this conversion because it's trivial. We don't need to make a network call to this and a network call to this and a network call to this. So I'll eliminate these three network calls with one, and that one will simply wrap this function. Well, it'll be two network calls, one to the wrapper and then one to this. So we'll eliminate one network call with one set of generated code. Okay.